Hello students, today we can start a new chapter, chapter 10, circles chapter. We have to recap few geometrical terms which we studied before. Let us study that. Point. Everybody know what is point? Suppose this is the geometrical representation of a point. This is a point. It has, or you can write, suppose name this point, it is P. P is a point it has no length, no breadth and no height. No length, breadth or height. When so many points like this, so many points lie on a plane, the number is so many or infinitely many, then what we will get, that let us see. Then we will get a line, infinitely many points, one after another, if they lie on a plane, that will be a line. And obviously it is a straight line because no changes in direction. If it changes direction like this way, then it will be a curve. So we can name the line, take any 2 points A and B. After point B right side it is endless, and after point A left side it is also endless. How many points lie on this line AB? Infinitely many. AB is a line or we can say straight line. If it does not change its direction, then it will be a straight line. Can be written or represented as AB. AB is a line or straight line. It can be represented as AB and above both side arrow with a single line segment. Its length is infinite. And infinite number of points lie on a line. On it you can write. it has no end point. Both sides can be extended infinitely. Let us take a small part of this line. Suppose this part we have taken. We can take this part also, AB part also. How many points lying on this part? Infinitely many. What is its length? It has finite length. And is there any end point? Yes, two end points are there, point A and point B. So following this we can write AB is a line segment obviously it is straight. Can be represented as AB like this. Its length is finite. That means each line segment has some fixed length and infinite number of points lie on it. Infinite number of points lie on it. This point is same for line also and line segment also. Infinite number of points lie on a line also, on a line segment also. For a line it has no end point, but for a line segment it has two end points. It has two end points. In this diagram it is A and B. We can write A and B. From this line, if we take this part, let us see. One end point and another side can be extended infinitely, and one side is only one end point is there. This is called a ray. AB is a ray. It is also straight. Can be represented as for an A, one end point is there, this point. Suppose it is A. It is not end point because this side can be extended infinitely. You could take this way also. This is end point. This side can be extended infinitely. This will be also a ray. its length is infinite like a line, because this side can be extended infinitely. Its length is infinite, and infinite number of points lie on it. This is also true. And infinite number of points lie on it. It has no endpoint. It was for a line. For a ray, it has one endpoint. It has one endpoint. That is point A. We can write A. All these things you studied before also, just for recap purpose. We are discussing these things again. Next part. Let us know about curve. Curve. First, we are discussing the curve for open curve. A curve which is open. Suppose C, this C is a curve which is open. This L is also a curve which is open. Open curves. And all these are located on a plane, that means plane of the board. And all these curves has two endpoints. This is one endpoint, this is another endpoint. For L, this is one endpoint, this is another endpoint. This is not the endpoint, because this curve is continuing like this way. V, it is also a curve. It has two endpoints. W, two endpoints, not this and this. They are not the endpoints. This is also a curve. So what can we say about these curves? They are all plane figures. Infinite number of points are locating in each curve, and each curve has two end points, and these are the open curves. Now, if we draw, keeping some fixed distance, if we draw a curve like this, suppose this was the fixed point when this curve is drawn. So what is the difference between these curves with this curve? For all these curves, take any one point outside this curve, and if you join with this, with the points which are located on the curve, we will get some distances. These distances will not be same. Suppose for this point is located on the curve, it will be some distance, and here one more point take and join this, we will get distance. These distances will not be same. But this is the special case. If we join any point on this curve with a point which are not located on this curve, and that point is fixed point. One point you will get from that point, the distances, that means this is the distance, suppose this is the point P, this is the curve, open curve, fixed point is A and B. From point P, PA distance, and PC, same, D, E, F, G, etc. We get PA, PC, PD, PE, PF, etc. Distances are same. Later we will discuss about this curve again. Now closed curve. This is a closed curve, or this is also a closed curve. Like this, different curves we can draw which are closed. That means any end point you will not get. But if we draw a closed curve like this, and suppose this is the fixed point, if we see that the distance of this fixed point to a point lying on this closed curve is same with this fixed point lying on this closed curve with another point. Suppose this point was A, this point was B. If we see this point, fixed point, let us suppose it is O. Then if we see OA equals to OB like this, equals to OC equals to OD equals to OE, etc. Then this closed curve is called a circle. It is also a plane figure. So, when infinitely many points together make a closed curve, and all these infinite number of points which are located on this curve, maintain a fixed distance from a point inside this curve, which is located inside this curve, then the closed curve is called a circle. So we can name this closed curve a circle. Already in the book also circle definition is given. A circle is a collection of all points in a plane which are at a common distance from the fixed point. This is the fixed point. All the points, collection of all these points are located at a fixed distance from a fixed point, that means point O. This collection of points is called a circle, and this fixed point is called as the center of the circle. And fixed distance, suppose this distance is r, that means it will be r for OE also, radius it is also. This fixed distance is called as the radius of the circle. And circle can be represented as, suppose C with center O and with fixed distance, that means OA, OB, OC, etc. That distance is called as the radius of the circle, R. Arc. If we take some part of this circle, that will be arc. Suppose this part, AB, suppose this much we have taken. Then point A, B. This AB will be called as arc, and it can be represented as arc AB, or this radius is taken as R, that means OA equals to OB is equal to OC, etc. It is the radius of the circle, and radius or radius. And center is point O. Now, if we draw a line segment, we start from a point located on the circle and passes through the center straight to another point, suppose XY, passing through the point O, that means passing through center, and it is a straight line segment. XY is a straight line segment. Now you can see that this straight line segment contains or is consisted of two parts, XO and OY. What is XO? That is also R, and OR, that is also R. Then this XY is called as the diameter. So diameter is denoted as D, and D is double the radius. We can write or we can write radius is half the diameter, D upon 2 means half the diameter. Next topic, a line and a circle. Already we have studied what is circle, what is center of the circle, what is the radius of the circle, what is the diameter of the circle, and the relation between the diameter and radius of a circle. Also we have known the arc of a circle. Next point, a circle and a line. Three possibilities are there. First possibility, let us see. Suppose this is a line. You can give the name of the line like this, A, B. Suppose this is a circle, its center is O, radius is R. Obviously, the line is non-intersecting. That means there is no common point. Which point can lie on this line also and on this circle also. No common point between AB, line AB, between line AB and circle COR. Second possibility. Suppose this is the circle, center is O, radius is R. If the line just touches the circle, it is one single point. The line AB touches the circle or intersects the circle at one point. Let that point be P. The line intersects the circle at one and only one point. For this case, AB touches or intersects the circle COR at one and only one point, namely the point is P. Now one question may arise. For this point P, how many tangents can we get? The answer will be one and only one tangent. A circle, in a circle, infinitely many points are there. This point, this point, this point, infinitely many points are there. For each point, we can get a tangent for this circle. So, infinitely many tangents can be drawn on for each point of this circle, but in any one point, for any one point, we cannot draw more than one tangent. another points for this case I am writing. One end, only one tangent can be drawn at P. Only one tangent we can get for this point P. A circle has infinitely many tangents. At infinitely many points lying on this circle. Infinitely many points are there, so infinitely many tangents we can draw. But for a single point, we cannot draw more than one tangent. One and only one tangent we can get. Now, third possibility. Suppose this is a circle, center O, radius R. This is the line AB. This line AB intersects the circle at two distinct points, this point and this point. Suppose this is P, point P, this is point Q. AB intersects C, means AB intersects the circle at two distinct points. Namely P and Q. This line AB is called as the secant of this circle. AB called as the secant of the circle COR. So now we can ask one question. A secant can intersect a circle for 2 points or more than 2 points. For 2 points it is possible, but more than 2 points it is not possible. A circle and or you can write a secant of a circle cannot intersect the circle a secant of a circle cannot intersect the circle at more than two points. That means there is two and only 2 points are there which are common for this line AB also and for this circle also. This point I am writing here. Two and only two common, two and only two common points are there for the line AB and the circle COR. Observe this line AB and this line segment PQ. PQ is the line segment of this line AB. This line segment is a part of this line AB. Then PQ, this line segment, is the part of the line AB, which is called secant for this case. Is called as the chord of this circle. Now, how many chords are there for a circle? It will be infinitely many, because this is a chord. You can draw another chord, you can draw another chord like this. So infinitely many chords are there for a circle. We can draw this. This is also a chord, this is also a chord, this is also a chord. So infinitely many chords we can draw. We can draw this way also. This is also a chord, this is also a chord. But if the chord passes through the center, this is the center, that chord is the longest chord. Suppose AB. So we can write infinitely many chords are there for any given circle. Now, out of these infinitely many chords, which is the longest chord? out of this, the longest chord is called as the diameter of this circle, of the circle. This one more term we have got. Say O to A, this much length is the radius of this circle, and O to B, this is also the radius of the circle. Then we can write, this is the diameter. Diameter means 2 times the radius, because AB means OA plus OB. OA is the radius of this circle, plus it is also the radius of the circle. AB means diameter, so we can get D is equal to 2R, twice R, or R will be the half of this diameter, means D upon 2. For a circle, so many diameters we can draw. This is also a diameter, this is also a diameter, radius also. Suppose this is a circle, this is the center, this is radius R, this is also radius R, this is also radius R, this is also R. So many means infinitely many radii. Singular is radius, and plural is radii. Infinitely many radii can be drawn for a given circle, and infinitely many diameters also you can draw for a given circle. Diameter means the longest chord which will pass through the radius, the center of the circle. The longest chord which passes through the center of the circle. So infinitely many diameters are also there for a circle. The approximate weightage of this chapter is 6 marks. One more observation, let us check. Suppose this is the circle, center is O, and this is the secant. Suppose AB. AB is the secant. It intersects the circle at 2 distinct points, P and Q. If this line AB or secant AB moves this way, then the length of PQ, this will decrease. Suppose next it will be this, next it will be this, like this way it will decrease. One situation will arise when the points P and Q will be the same point, superimpose each other or coincide each other. P and Q, when they coincide each other, then we will get a tangent. That's why we can say that a tangent is the special case of a secant. When the points P and Q of the secant coincide at a single point, suppose it is X. When P and Q will coincide at the point X, then the line AB will become a tangent. Suppose this is a circle, its center is O and radius is R. If we take some part of this circle, suppose this much part we have taken. Let us name A, B. This much part is called as the arc of a circle, and this is the chord of the circle. This part is chord. From this circle we have taken one part of this circle. Then AB, this curve is called as the arc of the circle, and AB, this line segment, is called as the chord of the circle. Suppose AB we have taken like this. This AB is the chord of the circle, and this curve AB is the arc of the circle. Arc we can write like this way. AB, this symbolically we can write this way. Chord, we can write the line segment. AB is the chord of this circle. Let us recap once again. Suppose this is a circle, and this is the center, this point. We can name it as O. This is the radius of the circle. This is the diameter of the circle. Suppose A, B, C. We can name the circle like this way: C, whose center is O and radius is R. R is called as radius, and R is what? OC. And AB, it is the diameter, of the circle. If we join these A and C, AC will be the chord, and this part AC, all these are line segments. You can write like this, and AC you can write like this. It will be the arc of this circle. This xy will be the tangent to the circle. You can write xy tangent to circle OR. Suppose it is PQ, it is intersecting the circle at 2 points. These 2 points M, N. Then PQ will be the secant of the circle C, OR. So about circle, we know the radius, diameter, chord, arc, tangent, secant, and the relation between the radius and diameter also we know, because R we get diameter upon 2, means half the diameter, and diameter is twice the radius, means 2 into R. Here it is given, the tangent to a circle is a special case of the secant when the two end points of its corresponding chord coincide. Suppose this is a secant PQ. It touches the circle at 2 points MN. MN is a chord, and M point and N point, these 2 points M and N are 2 distinct points when, and Mn is the chord of this circle, and this chord when its length diminishes and points M and N coincide at a single point, that is the point A here, then it will become a tangent. It is a special case. Approximately all the points we have discussed. The common point of the tangent and the circle is called the point of contact, and the tangent is said to touch the circle at this common point. So we can give the name, this A is called as the point of contact. This common point A of the tangent and circle. This point is lying on the tangent also as well as on the circle also. This common point is called as the point of contact. Okay, today I have to stop, and next day we will discuss about theorem 10.1, exercise 10.1, and theorem 10.2, as well as the number of tangents from a point of a circle. Okay.